Hey friends, and welcome to the Adventures of Blink. I am of course Blink, and you can find me on GitHub right here. Now, today is a really exciting day for me because we're going to start digging into the fundamentals of Git. We'll clear up a few misconceptions and walk through some basic operations so that you can begin to use Git to manage your source code. And when you finish this video, my goal is for you to be able to use Git on the command line with confidence. Now, before we delve into those commands, we need to make sure that we're going to all be on the same page. So, Git is what we call a distributed version control system. You interact with it primarily through the command line on your terminal. The important distinction here that I'm trying to make is that it's not a website. GitHub and GitLab are server applications that provide a web-based interface with Git repositories. They're what we would call a SaaS platform, software as a service. You can go sign up on GitHub and create an account, and then you can start loading your Git repositories into it. But it's really important to note the distinction between a Git repository and something in GitHub. See, anything that happens in Git is going to be portable across all the different platforms. So if you want to move from GitHub to GitLab to Bitbucket to any of the other places that you can put them, using Git is what does that. Git is the core of what we're doing, and then GitHub, GitLab are just the platforms in which we share. So it's important to have that distinction in your head. You'll hear people use them interchangeably and maybe not necessarily correctly, but that can be a little pedantic. So, it's kind of comes and goes. You work with what you got. But the general gist of what we want to talk about is that Git is a way that you interact on the command line with source code. Okay, so the first thing we're going to do is create a repository. Now, a repository, or we'll often call it a repo for short, is just a folder on your file system where Git has been told to go pay attention. And so you can create a Git repo inside of a blank folder, like we're going to do today, or you could actually do this on the fly inside of a folder where you've already written some code. You could have a fully working application and you say, hey, I would like to push this into Git, and then you can start initializing a Git repo within that folder without interrupting anything. It's just a couple extra steps to start the tracking process, which we'll go over a little bit today, and then you're good to go. So I'm going to use this season 3 folder that you see here, and you'll see that it's blank, and that's what we're going to be building in as we get started. So I'm going to shift over here to my editor, and you can see I don't have anything connected yet. So what I'm going to do is open a folder, and I'm going to go to Documents, to Season 3, and open that up. And so my editor pops up here where it's ready to go, and then I can do Control-Shift-tilde is the terminal in VS Code. If you're playing along at home, that's a handy one to remember. Control-Shift-tilde will give you your terminal. So you can see I've got my empty folder here, and I've got a terminal ready to go on the Season 3 folder. Like that's where I'm navigated to in my structure. So in order to create a Git repo, I'm going to do a simple command, which is git init. Okay? And you'll see it says, hey, I've initialized an empty Git repository in this folder. Well, that's cool, but we don't see anything over here to let us know that it's happened. The only change that you'll see in VS Code is down here. You'll see that we're actually on the main branch now, which that was blank before. But now it shows the word main to let us know that we're in a Git repository and it's recognized it. We'll not talk about branches today. That's a future episode. Stick around for next week, I think is when we're going to cover branching. But suffice to say, that's how you can tell you're in there and you're ready to go. Now, what you could do, you could look for this .git folder. It's a hidden folder, so if you just do an ls-al, you can see all of the files that are in here, including the hidden ones, and .git is a folder inside there. So Git uses this hidden folder to store all of its information about how it's tracking the repository. That is not going to become part of your project. That is going to be something that is kept off to the side and used to manage your project. So that's why it's a hidden folder, so that it actually won't show up here and become a nuisance in your editor. But anyway, we've now created our repo and we're ready to get started on some things. We've told Git to track the files in this folder, and that's cool, but in order to store changes, we have to commit changes to a repo. So let's go over here and actually make some changes. And I'm going to just open up a readme.markdown file, because every good project should have a readme. But let's say, this is my example of using Git. Okay, so I've now made a README and I've put some stuff in it. And you'll see it shows here as untracked. That's what the U means. And you can see when I highlight VS Code, it'll tell me that's what that is. So Git is currently not paying attention to that file. Git will wait until you tell it what files to pay attention to. So the next thing we're going to check is a Git command called status. And we're going to do Git status, and we can see that we're on branch main. We have no commits yet. And we have one untracked file, which is readme.md, and there's actually a handy link to get to it. One of the cool things about the Git command line interface is that it usually tries to hint at what it thinks you're about to try to do. So in this situation, it's decided that git add is probably the thing it wants to recommend for you. And it's exactly right, because we want to tell Git to start tracking our README to make it part of this project where all of the data would be stored together. So what I'm going to do is git add, and I'm going to tell it to track the README. Okay, now we've seen a change in our editor here because the U became an A, and it now means that it's been added to an index. So it's ready to commit. Okay, and if I look at Git status, we'll see a different display here where it now shows, hey, I'm tracking this new file. And if I decided, I didn't mean to track the README, I wanted this to be something that was in the folder but not part of the project, then I could do a git rm -- cached readme.md, and it would pull the file out. But in this case, we actually want to store it, so we're going to leave it there. And so the next thing we're going to do is to commit our change. So we've made a change, but it's not actually part of the Git repository until we tell it for certain that this is what we want it to do. Okay, so the next thing we're going to want to do is a commit. Now, a commit is how we tell the Git repository this file or this set of files needs to be added as a unit to our project. These are going to be all pushed up together, and they're going to have a little comment on them to let us know what it is we were doing when we pushed them up for documentation purposes. And so this is the sort of the unit of work in Git, if you will, is commits that you add to projects. So how do we select what goes into a commit? That's kind of a good side question that we can answer while we're here. A commit should be small. It's dangerous if you add 85 files to a commit. Not because it could break anything, it's not like it's technically a problem, but the problem comes in the way that you and I as humans interpret the information we're seeing. If you're reviewing commits and you see one that has 85 different files in it, you're not going to know that all of those 85 things are directly related to whatever's going on. Now, there are some cases where that's a little different, like if you had an existing project and you're migrating into Git, then of course you would commit the whole project in one shot to say this is our current snapshot. And that's valuable. But generally speaking, if I'm just doing day-to-day work, I don't want to end up in the place where Git has a ton of files. So I should keep my commits small. They should have narrow scope, and they should be really focused. The other big point I want to bring up here is that commits should be related files. So if I'm making changes for one kind of feature and then I decide, I need to do this other kind of feature, and I end up like merging them all together in the edit, then I have this commit that now has this mesh of two things instead of one. And it's really good practice for us as software engineers to think about separating our work out into bite-sized units that are meaningful on their own. So if I'm doing two different features, I should probably put them in two different commits just to keep the work separated. Even though they're going to end up mashed together in the final app, the fact that I build them separately gives me some control over when things go in and out of production. So it's really important to keep your commits small and keep them on related topics. So don't let them wander around from topic to topic. Now, we've added our file for the commit here and we're ready to commit it. So we're going to do git commit, and one of the things that's a feature of the commit command is the -m flag for message. So we have to provide at some point in the process, Git wants us to put some documentation here about what it is we're changing. So in this case, it's kind of small. We would do something like add readme, right? And that's enough of a message. Now these commit messages should generally be really informative, but not overly detailed. We want to keep it short and to the point, mostly because things like GitHub and GitLab will actually display these on the web page so that you can see the commit that changed the file last. And you want to make sure that that message is there as a easy breadcrumb for a person who's clicking through to find what they want to work on. Oh, look, there's the thing I have to go fix. That'll give them some sort of visual cue. But at the same time, you don't want to pile on a ton of information where they have to stop and read a paragraph about every commit. So that can get overwhelming. The balance here is to put in, a sentence or two that just explains what it is that's going on in this thing. Try to keep it really short, like a one-liner kind of commit message. But there we have commit -m, and we put add readme. So that should be enough to go on that, and we're going to do a commit. Now you see that the editor has actually changed our display again. The file is up to date with Git, and so it doesn't have a marker. And in fact, we could see that we can change something in the file. Like if I come in here and say, this is my first edit, okay? And then I'm going to save the file. And the moment that I save the file, it marks it as modified. Right? And so now it says, hey, this is one of the files that's going to show up in Git when you do git status. And so then I see, oh, look, I've modified readme. So in this case, you would do git add again. And there's a way to skip this. In fact, you know what? I'll actually show you here. So we could just do git add readme.md and go to the commit command and all that. But it turns out that commit for files that are already in tracking and you're just making updates actually gives you the ability to do a -am, and that's going to say grab all the files and add them, and then all the currently tracked files. So if there's a brand new file that you've added, AM won't pick it up here, but anything that's already been pushed into once before, you can do this way. And then you would say first update, right? And so there's my commit, and now you see it marks my file as up to date again. So now I've got the ability to make changes and commit them to Git. Now, on the note of commit messages, it's important to note that if you're working in an organization, if you're with a bunch of other developers, there are often standards for what goes into a commit message. Some places will actually prescribe that you would put like your Jira ticket number that you're working. So as you get work assigned to you in Jira, it'll give you the ticket number, 57. And so I go to ticket 57. And so you would actually start your commit message with that as an easy visual way for people to see what caused the change to be made. Those are important things for people who aren't software engineers as well, especially if you're in a security and compliance sort of organization. You want to know what changes introduced things that happened in the code base. So as you change the code base, you want to know why those changes came to be. So that's kind of cool. We are actually able to take code changes and commit them into our Git repository so that they're tracked by the Git program and accessible to us in these little chunks that we call commits. But what happens if we accidentally committed something? Or maybe we changed our mind and decided that wasn't going to work. Or maybe we made a change and it broke something and we needed to undo it. It turns out there are two options for how to alter your commit history like that. You can use git revert or you can use git reset. Now, git revert is going to add a new commit that contains an inverse of the named commit. So let me see if I can show you a quick example here. For instance, the last update we made here was this B19763F, right? And so let's say that I decided I don't want to have that change in my code anymore. I need to undo that. So the way that git revert will work is I do git revert and then I do B19763F. Okay, and when I do this, it says, hey, this is your commit revert. It actually drops you into Vim because I didn't put the -m flag on here. So when you're doing commits, if you don't add your commit message on the command line itself, it will force you into a Vim editor that lets you update your commit message there. I'm just going to keep the message that they provided as the default. So escape WQ gets me out of Vim and saves that update. And you see it's now forced the reversion and my file has actually changed. Now, one of the interesting things to see here, and I'll clear this so you can see it more clearly on the screen. We're going to do git log and look at the history of what happened. So here we see the very first commit was me creating my database, or me creating my Git repository, I should say. And then I see this commit message, which is my first update. And now I see a new commit message that is the reversion of first update. So a git revert will give you the ability to preserve that history while you're making updates. Okay, so the other way to eliminate a commit from history is actually to erase it. And so you can use git reset to do that. You can do git reset, and that's going to come with 3 different modes. So there's soft, and there's hard, and there's mixed. Okay. Generally, I find myself not using git reset unless I need a hard reset. I don't really explore the other options, and quite frankly, once you get into the flow, there's a lot of things within the Git ecosystem that you're only going to use once in a while. And it's perfectly okay to go ask ChatGPT or look on Stack Overflow for how to do those things when you get into those one-off sort of scenarios. Don't ever think of yourself as being less than because you have to look up how the git commands work. There's a ton of arcana in here that you don't necessarily have to use, but maybe once a year or something. So perfectly okay to just skip that out. But what you would do is then put the commit ID in here. And what this does is instead of adding a new commit that inverts the previous like git revert did, git reset is going to pick up the pointer and it's going to move it back to that commit and say everything after this never happened. So we're going to go back to that point, and that's what's now in our code base. Much more destructive, much more dangerous, and so you need to be very careful when you use it, but extremely powerful for what you need in those moments where it's necessary. Okay, so the last thing we're going to talk about today is keeping the pollution down in your Git repository. There are some files that you should never, ever, ever push into Git. Not because they're dangerous to the application running, but because they just don't belong there. For example, let's imagine that you're working on an application that connects to a database. That means you probably have some database credentials lying around. Here's my user ID, here's my password so that I can start up the app using these credentials and make everything run. Now, if you push those into a Git repository and someone else gets into that Git repository, they're going to have access to your credentials. And that's a big no-no, right? You've opened a huge security hole, and that's not appropriate behavior. So we want to make sure we don't ever put those kind of files in there. Another case that you might think about that's maybe not quite as dangerous, from a security perspective, is build artifacts. If you've ever written in C or C++ code, you run the compiler and it creates like a .o file, right? And then you have to run the linker to put all the .o's together. And then once you've assembled all the objects, you can, do the final compilation that produces the executable. But all of that stuff happens in a series of files that are created sort of in a temporary process. And those files don't need to ever be pushed to Git. They take up a lot of space. They don't have a lot of value because they're not direct source code anymore. Once they've been compiled, you can't like open them up and read them to see what's going on. It's all been converted to machine code and unreadable, human unreadable things. So those kind of files aren't really appropriate to keep in a Git repository, and they'll just clutter up the space and maybe cause problems, because if it's been compiled for one type of architecture and the .o gets pushed up there, then it might interfere with someone else trying to build this on a different architecture. So we have to make sure we're cleaning up after ourselves and not allowing things into Git unless they belong there. So how does that work in Git? As it turns out, there's a construct called a gitignore file that we're going to add to our repository that's going to tell it what files in the folder should never ever be tracked and eliminate them so that Git never sees them. Let's take a look at how that works, shall we? All right, so I have my repository here and I'm about to add some credentials. So I'm just going to do like credentials dot text, right? And then I would do user equals blink and password equals 1 2 3 4 5. It's the combination of my luggage. All right, so I save that, but I don't ever want credentials.txt to be pushed into my Git repository. That would be dangerous because then I'm giving my credentials to anybody who opens this code to work on it. They should have their own credentials. So in order to eliminate that, I'm going to add a .gitignore. Now, you usually only need one of these in the root directory of the project. As it turns out, you can put them in several different places throughout. Like you can have them in any level folder, and you could customize the gitignores for that folder if you wanted to. Generally speaking, though, that's a little bit more hassle than it's worth. Technically, it's possible, but why would you ever do that? So we create one gitignore for the project that lives in the project root, and it will contain all of the things that we want to ignore. So in this case, I can do credentials.txt, and the moment I add that to my gitignore, Git stops paying attention to that file. It can no longer be committed to the repository because from Git's perspective, it does not exist anymore. So the next thing to do then would be git add my gitignore and commit adding gitignore. Oops, I forgot my -m in the middle of that. Get to type in and forget what I'm doing. There we go. All right, so now my Git repository will never accept a credentials.txt file. So as long as you put it where I'm expecting you to put it, it's never going to make it into the project. And that's valuable because that's a safeguard that I'm putting in place. That's a guardrail that I'm personally adding to the project to keep myself safe, keep myself from making a mistake later. Now what's cool about gitignore is you can do path things with this too. So if I came up here and just did like folder 1 and let's put a file in here, so file1.txt, and I say I want to ignore the entire, oops, I didn't mean to close the gitignore file. There we go. I want to ignore the entire folder 1. So I could do folder 1 and save. Or I could do folder 1 file star. And now it'll keep the folder, but it will eliminate the file or any files that start with the word file. So I have the ability to do some controls like that that let me manage my files and folders in a way that I keep my Git repository clean. Now, in general, I'm just going to remove this altogether because that's completely contrived example, but you see how it works. Gitignore gives me the ability now to control all of that. And all I have to do is add a new update to the Gitignore whenever I have a path that shouldn't be included. So usually what happens for me is I run my project for the first time, like I compile everything and let it go through the process, and I look to see if there are any new folders or files that have been created from the build process. And if there are, I ignore any of those files so that they don't make it into the Git repository. What you should be putting in Git is the minimal amount of stuff that someone needs to be able to take your project and build it somewhere else. They're still going to have to know how to build it, but at least this gives them only the things they absolutely need. An important thing to note here is that it's really necessary to do this early in the process. You don't want to go through, a couple of months of commits before you realize, oh, we needed a gitignore file. You need to take care of that up front so that you don't risk having things in there. Because remember, if you ever commit the file into Git, it's going to remember that in the commit history forever. Even if you revert that commit, it's still going to show up in there in history where it can see, oh, look, we made this change and we included credentials.txt before. So at the moment you commit any credentials, for instance, to Git, those credentials should be invalidated and rotated, and that way you don't end up risking someone getting a hold of something they can use. Wow, we covered a ton of ground today. We created a new Git repository and we added some files into it, and we committed things and we reverted the commits, and we added a gitignore so that we could control the data that's being passed into it. We have enough knowledge now to be able to use Git on a regular basis as we're writing code. And that's a really important step, because even if we're not using the full functionality of Git yet, Git is about habits as much as it is about technical capabilities. So you get in the habit of using it to do things, and you remind yourself to do these things in a certain order, and you get better at it. So if I can give you some advice, that's what I would want you to do, is go practice just doing these things. Make sure that as you're writing code, you're always committing it into the repository. You're building the habit of being able to do the commits, small and targeted commits that are focused, so that you have a well-defined path for your software as it grows. But there are a ton more features we're going to explore, starting next week when we start to dig into branching and merging. So come back and see me then, and let's see if we can learn some stuff together. That wraps it up for this episode of The Adventures of Blink, and I hope to see you next week. Have a good one.